Look, I'm just a geologist. I like rocks. I love rocks.
All right. Hello, everybody, and welcome to the Geology Flannelcast. My name is Steve.
Hey there, everyone. This is Chris.
First, hello. Secondly, I feel like I'm about to be attacked. I'm Jesse. Also,
We were just talking about something. I said save it for the podcast because Jesse's going to drop some knowledge bombs on everyone. So this is, by the way, FYI, if you only want to listen to the geology, just fast forward like 5 minutes from now, because this has nothing to do with geology.
And if this is your first podcast, do we go off on tangents? Yes, usually not first thing, and usually not about food products.
All right, Jesse, tell the world what you just told us.
So I was just eating a Triscuit cracker, I guess you would call it. It's a cracker.
Yeah.
And the name Triscuit is derived from when it was first made in the early 1900s by Nabisco. They used electric ovens. And so Triscuit comes from electric biscuit. Triscuit.
There you go.
Yeah,
I didn't realize Nabisco was the national biscuit.
I was more like,
that
wow,
blew my mind.
That's where Nabisco
And
came from.
they're from Philly too, aren't they?
Yeah, the National Biscuit Company.
Yeah.
When did
Crazy.
Nabisco shorten their name?
Oh, that's a good question. Probably find out.
Probably when they went public.
Uh,
Shorten it to something for the stock exchange.
1898.
Exactly.
That's when they were founded. Yeah.
Oh, hold on. In 1898, the New York Biscuit Company and the American Biscuit Company American Biscuit and Manufacturing Company merged for the National Biscuit Company, later called Nabisco.
Ooh, I like that. It's like a dream team of biscuit makers.
Right? Man, the early 1900s must have been full of biscuits.
Oh man,
A box of biscuits, a box of mixed biscuits, and a biscuit mixer.
Wow.
It's a tongue twister. It's hard to say.
I also I don't know if this is true, much like all of the facts I give you. Hydrox predate Oreos.
Oh, yeah, I've heard that. Yeah.
Huh. So
Well, there's a marketing failure for you.
yeah. Oh yeah, I'm looking at
1971, Nabisco became the official brand name.
yeah.
Nice. The year Seminac was born.
In 71?
Yeah.
No.
61?
What? The wrong direction.
Pushing 60.
61 was the year you were born, my friend.
That's right.
All right. Enough fun facts about bakeries in America. Very good. Thank you, Jesse, for that knowledge bomb.
That's what I bring. So
All
that's
right. Well,
I'm done for the night.
I can't wait to see what next week's snack is.
give me the history of goldfish next week.
Ooh.
All right. Well, everyone, welcome to the Geology Flannelcast. This is the premier geology podcast. Occasionally we go into bakery stuff, but how's everyone doing today? Everyone doing all right?
Yeah. I'm running and gunning today.
It's March.
Good for you.
It's almost mid-March. And
Yeah. We still need to get on our mineral March Madness.
Oh, that's what we need to do.
We got time. The real March Madness doesn't start until next week or the week after. So
selection Sunday is Sunday. We'll see what we can do by then.
All right.
So did you hear Drexel's in?
Yeah, first time in 25 years.
Yeah.
Temple plays tomorrow at noon.
Which is crazy because I feel like I remember the last time Drexel was in. It doesn't seem like 25 years ago.
1961 when you were born.
Touche.
Wait, I'm doing the math, and that doesn't.
It's in Celsius. It's fine.
Oh, okay. Celsius.
9/5 is of
Metric
it minus
years.
32.
Yeah.
Very good, gentlemen. All right. You want to? We're just hanging out today, doing some news stories. We haven't done any news stories in a while, so figured change it up a bit. We've been doing, lately we've been doing whole topics per an episode. Does that make sense? Whole topics, an episode devoted to a single topic. Then
there you go.
That's the better way to say it. So today, I just kind of go back and just kind of talk about some news stories, things that are just kind of that sparked our interest over the last week or so.
Yeah, but if you have any specific topics you'd like us to cover, drop us a line, as the kids say. Go to the geologyflannelcast.com and send us an email.
Yeah. All right. I'll start it off. So
Okay.
Do it.
here we go.
Yeah.
All right. Let's go back to this story is about like Precambrian time, really, really old Earth time. And this is kind of hot off the presses.
Before Chris was born.
Before even older, before Steve was born. Right.
Yeah. Precambrian, hot off the presses. Are we in the Hadean?
Ayo!
No, I don't think so.
No, not for this one. So this story is talking about there's a study that was conducted. It looks like it was led by Junji Dong of Harvard University, and they were talking about, there's then this question, was the Earth ever covered in oceans? Just like nearly completely covered in water.
I mean,
Water World.
I've seen this movie.
Yeah. Kevin Costner's one of his finest.
Sand.
The
Sand is
opening
your
scene where
currency.
Yeah. The opening scene where he drinks his pee is not for me.
Usually not many people enjoy.
'Cause-
I guess Kevin Costner movies are really not for that many people either. So
It's
sterile,
sterile,
is that a
and I
bird?
like the
Costner.
taste.
Yeah.
all right.
Anybody? Dodgeball?
I haven't seen Dodgeball in years. I don't remember any of the lines from
Anyway.
that. So if the Earth was covered in ocean, like in water, the great question is, where'd all the water go? Right. So what this recent article looks at is the Earth's mantle. Maybe it went into the Earth's mantle, and that's what they're suggesting in this article. That the water, we've talked about this before in the podcast a few times about how the Earth's mantle holds water. And don't think of it holding water as like an aquifer or something like that, or like these like underground oceans. It's a little more complicated than that. But instead, it absorbs water and holds water in minerals, hydrous minerals that have H2O in their chemical formula. So looking at this, this group determined that the amount of water that the Earth's mantle can hold is related to the temperature. All right. So if we go like way back into Precambrian time, like early Earth history, the mantle was hotter. And so when the mantle's hotter, it doesn't hold as much water. But as it starts to cool down, it can hold more and more water. So that's this hypothesis is that, potentially the Earth could have been covered in oceans, and now everything is the mantle cools down, and then all of a sudden the mantle can absorb that water in the form of holding it inside minerals. So specifically, they're looking at some of these minerals, different variations of the mineral olivine. We're looking at wadlasite, wadselite, and ringwoodite. So they're different variations of olivine, and they hold an H2O molecule in them.
I think so. The ringwoodite that made news sort of recently in the discovery of it, and that it could hold water.
Yeah.
I think we talked about it on a previous episode.
We did. We didn't go in too much depth, but it definitely has come up that that's how it's held. I have questions as to how does ringwoodite precipitate? Are you telling me the mantle was liquid?
No, I don't think the mantle was. I mean, the mantle wasn't liquid. The mantle's solid.
But how does the water get in there?
Is it when it like recrystallizes? I think because it's as you go deeper into the mantle, the olivine or whatever, perovskite gets compressed, and it turns into other forms of olivine group minerals, right? It's basically metamorphosing. And
Yeah,
so is it during this process, maybe?
no, I mean, from what I was reading, it didn't really go into the process of how the water gets into the mantle. That's a very good question. I didn't even think of that. How, yeah, how's that water getting from the surface of the earth down into the mantle? I'm sure in the paper they get into that, but
I mean, it's a pretty cool idea, and it is I think the idea of, as the mantle cools off, there was a point when the mantle was molten, right? Because the entire earth was molten.
sure, yeah.
And the mantle has been cooling since earth formed, as has the rest of it. And it's cooling basically from the surface inward. And this idea of, in terms of earth heat inside the earth, we get it from three places essentially. There's some radioactive elements that provides a little bit of heat, and the core, as it cools off, crystallizes, and that's exothermic. But the majority of heat inside the earth is just left over. And so the earth is getting cooler. And so that's an interesting, I never even thought about that. Like, how is that cooling going to, say, affect these minerals? That's really interesting.
And the other thing that they were talking about is that there's been this assumption that the volume of water in the oceans has remained nearly constant throughout geologic time. That might have to get reassessed.
I could see that. To me, the first thing that stands out is that I mean, there was much less continental material at this time. So like the idea of the planet being covered with water, I don't know, isn't that much of a stretch in my mind.
But also, how do you prove it?
Well, I mean, was it mid or late Archean? I forget if it's mid or late, but at that point, 85% of the continents had been 85% of the continents that we have today had been formed.
Really?
Yeah, and I want to say by the end of the Archean.
I never heard that, but that's interesting. Huh.
And then by the Proterozoic, it was something like it had only jumped up to like 90% of the continents.
That makes
so there's during the Archean, I mean, the continents they popped up during that time period, and it was.
Yeah, that makes sense, but I didn't realize it was that high. 85.
Yeah, I guess, when do you start seeing sedimentary rocks?
I think when the sedimentary rocks really start, I mean, I believe you can see them from Archean stuff.
Yeah, you get.
But really in the Proterozoic, I was just reading this today, and in the Proterozoic is when you really start to see a lot of these like fluvial systems and more of the classic stuff we see, but they do go back to Archean time.
Right, but would you get sedimentary rocks if the earth is covered in water? What sort of erosional processes would still be happening?
Whatever continents are there, I guess.
Yeah, I mean, they're not saying that there were like, if there were any little bits sticking up out of the water, obviously wave action would start to erode that stuff down.
Yeah, if they were sticking up, that's what I'm saying. But even if they aren't sticking up, I guess, would you still get erosion from currents? Maybe. I don't know.
It's a good question. I'm trying to think of like modern processes.
Yeah.
But I mean,
yeah,
that's a good question. I mean, it wouldn't be as much as you'd be getting if the stuff was on land.
Correct. That's what I'm saying. Like, could you theoretically get like something that looks like a sedimentary rock if the planet was still covered by oceans? Or is the proof that there's a sedimentary rock proving that the whole planet wasn't covered by oceans? That's all I'm getting at. Just trying to disprove these jokers.
No, but I mean, I think the point, they're not trying to say the whole, it was there was no land masses. They're just trying to say that it was, if there weren't any land masses, it was like few and far in between.
Got it.
Little bits sticking up
Got
out
it.
of the earth.
Yeah, so they're saying there was way less land 3.2 billion years ago.
So it was like Waterworld.
But this is interesting. Part of what they're getting into here is where early life evolves, and if it's forming in oceans or on ponds and on the land masses. And they're saying if the entire planet was engulfed by oceans, it would sort of solve that mystery.
Black smokers.
It could strengthen the case, in terms of looking for life on other planets like Europa or Enceladus.
I'm in.
All right. Well, Steve's in. That's all that really matters. So,
yeah, that's interesting. That is, well, that's that.
Yep.
Let's see how this
Let's stick a pin in that one.
No, but that is the rub of some of these really, really old pronounced, sort of theories. It's tough to prove or disprove them.
It is, and you can do things where you can be like, yes, the minerals can lock up some H2O or whatnot. It doesn't mean it happened.
Right. And if you can't tell me the mechanism as to how all that water got down there, then
yeah. But
so I mean, water obviously is getting down there. I mean, we see water vapors released from volcanic eruptions.
Yeah, from subduction and stuff like that. But
I mean,
was there just a ton of like little micro continents and microplates constantly sucking water down?
I mean, there's some type of water cycling going down into the Earth's mantle, and I think what I think the take home point of this is that just as the mantle was cooling down, this natural cycling of water that does go into the Earth's mantle, just more and more was getting absorbed into the mantle, and we're losing the volume from the surface. So whether subduction or, how much of do you think there's much of a percolation effect of the stuff just kind of just percolating down from the oceans into the mantle over time? I've never heard of anything like that, but
yeah, do like that, the percolation effect.
I feel like the temperature pressure regime would inhibit that, but who knows? Maybe there is some sort of chemical exchange going on at that.
I mean, we know that there is water circulation in oceanic crust around the mid-ocean ridges and stuff like that. So yeah, why? I mean,
yeah,
it gets down there.
Maybe hot spots not only bring hot lava up, they also bring cold water down. Prove me wrong.
Yeah, I don't know exactly how it's getting down there, but it's doing something. Somehow it's getting down there. That should be the next paper. Exactly how does the water get down there?
Yeah.
How are you doing this?
What is this? So, well, there you go. More and more water being stored in the mantle as it gets colder. There's your 1 second, your 1 sentence summary right there.
I like it.
All right.
Yeah, it's good.
Yeah.
I had a really nice plate tectonic animation I was just looking for, but
which should be great for the podcast.
Well, we could we have methods of posting this elsewhere into the void.
What is this? Oh, just tectonic, like a general tectonic model, or what was
yeah, and it's just for people to sort of visualize what plates were around 3 billion years. It's actually a pretty cool one because it puts a timeline of atmosphere, what the atmosphere was like, what life was around. It gives sort of big events.
It's not the Christopher Scotsi's
no
animation. They're cool too, but
They are.
shows-
Yeah, he does some good stuff. Anyhow, pretty cool. Pretty cool.
All right. Next article. Let's see. We kind of here's one we could talk about this one. I'm just going right through the list. We talk about sea level rise. All right. And this is actually we talked about this on one of the Patreon extra special Patreon content.
Yeah, you sent this to me, and I
Well, this
I've
one's
got-
a little bit different.
I've got some thoughts about it.
All right. Well, actually, hold that thought because
Yeah.
speaking of outlines that we have,
It's you. I like this edit you just made.
in the non-existent outline that we have for today.
How dare you? We're always well prepared. But yes, formattingformula.com or YouTube/C/formatting formula. They are your go-to one-stop, the buck stops here shop when it comes to formatting a Word document. Now, some of you may be listening and think like it's a Word document. How difficult can it be? And for, just bringing a simple paragraph, it's not that difficult. But for those of you who have had to try to write, table of contents and hyperlinks and glossaries and page numbers and headers and footers and all that stuff, it gets complicated and complicated and complicated. And then embedding figures, and then you have 27 figures, and then your advisor says, well, I want to change figure 2 and I want you to add one more figure. It's like, oh God, like, do you go ahead and renumber all of your figures? Well, the formatting formula can teach you how to do all that stuff, so it'll auto populate. If you change one, it fixes all the ones after it. And for even more complicated stuff, for like regulatory requirements and things like that, sometimes you have to have a very specific format to submit some of these governmental documents, and the formatting formula can actually customize your forms to make sure they comply with the government's needs. They can you can customize your header, so you have customizable headers, so you just click the buttons that you normally that you use all the time, and they can customize it for you. How many times I'll call them with a question, or I'll email them with a question, and they'll say something wacky like, well, just hit Shift F5. I'm like, I'm sorry, what? And they just know all this stuff off the top of their head. So formattingformula.com. Make sure you tell them the Geology Flannelcast sent you, and they will hook you up with some sort of unspecified discount. Yeah, I may or may not have just made that up on the fly, so I apologize, Formatting Formula. But yeah, check them out. YouTube/C/formatting formula. They have videos there that'll actually teach you how to do all this stuff. So you can try to learn it on your own, or you can take the easy way out like I do and just send them an email and say, here, fix it. So formattingformula.com.
Don't be afraid to take the easy way out.
No. They
It's
are
not
awesome.
the easy way. It's involves less headaches.
Yeah,
and
it's not working harder, it's working smarter.
Exactly.
yes.
Yes.
You got to be as efficient as possible.
Yeah.
We're only on this earth for 7-8 decades. Don't be wasting your time on Microsoft Word and stuff like that. You got better things to do.
That's a life lesson right there.
All right.
So back to sea level rise.
Yeah, Jesse said he's got some interesting things to say about this, but basically this article that we were talking about. I should say this first. On one of the Patreon extra content things that we were doing, we're talking about how San Francisco is sinking. All right, and basically it's because I should say sea level rise. We talked about this term relative sea level rise, you say, and it's the calculator. It's taking into account what the actual level of the water in the ocean is doing versus what the land is doing, right? And so San Francisco appears to be sinking because they're building a ton of stuff on there, and just that weight of all of the buildings and things like that in San Francisco is actually kind of starting to push the crust down a little bit. All right, so we talked a little bit about that in one of the Patreon extra videos that we do. But now this is saying this. There's another article that came out, and it's saying sea level rise affects coastal areas 4 times faster than we thought, and it's kind of going off of a very similar premise, saying it's we're not taking into account what's happening on the land. Is the land subsiding? So right now, global, what we say, like eustatic sea level rise, that's just only the sea level rise that's happening in the ocean. All right, that's the volume of water in the ocean is increasing because we have glaciers that are melting. Right, it's like you turn on, you have a bathtub full of water, and then you turn on the faucet, and what happens to the water level in the bathtub starts to rise. Right, so
glaciers are melting, and the water is heating up.
There you go.
Yes,
I was going to say that too.
Yeah.
That accounts for like some ridiculous amount of the percentage, like 20% or something.
I think it's 1/3.
Is it 33%?
I think so.
0.3.
So as the water heats up, it expands, and now you have more volume, basically. So yeah, that's the one thing. I always forget about how much of an impact just that the thermal expansion of water is.
Yeah,
It packs a punch.
So just real quickly, you said eustatic sea level rise, and so that's like you said, it's the volume in the bathtub. When we talk about eustatic, sometimes what we're talking about is global sea level. And so when we talk about global sea level, it's a tricky concept, because how do you measure sea level everywhere? How do you all of the oceans are sort of different. And so eustatic sea level as an idea is measured from the same reference point, which if you're on the Earth, the only common sort of equidistant reference point would be the center of the Earth. And it's not even truly equidistant because you have variations. But
I should say also, since we're on the topic of measuring sea level, like you're measuring sea level, it's incredibly hard. It's such a pain in the butt.
Yeah,
I mean, it gets.
Where do you measure it from? Where is there a pristine glassy surface you can take a measurement from on the ocean? Exactly,
because just think of you're sitting on the beach, right? Sea level, you're watching sea level go up and down every couple seconds. A wave comes in, right? And it comes up a little bit, and then the wave goes out and it goes down a little bit. You have tides coming in and out. Basically, it's always fluctuating. It's always moving around. Like what Steve said, it's not just this glassy water surface.
So we do it the old-fashioned way. We take averages. Do you know the two main ways we measure sea level?
Go ahead.
Guessing and squinting.
Guessing and squinting. A yardstick and a meter stick. So we get 1 in inches and 1 in meters. Nope, nothing. Anyhow, we have pretty good measurements with tidal gauges, because in areas, in harbors especially, you want to know what your tide levels are, because that affects shipping. And so we have pretty accurate tidal gauge measurements going back about over 100 years.
Yeah.
Oh yeah, like the 1800s.
Yeah. And since 1993, we've also relied on satellite data. So NASA's got some nice satellite, and you can go on. NASA's got a great little website, but you can see the rate of change based on the satellite data. And you can look at all the data on their site, but it's currently rising at 3.3 millimeters per year.
But you think about it though, without satellites, how do you know is your land sinking or is the water coming
Well,
up?
yeah. So that's
Well, so this is the giant
Yeah.
question right now. You're right.
that's
And this is, especially like when you're looking in the rock record, right? You're looking at ancient transgressions and regressions. Transgressions, it appears like your sea level's going up, or regressions, it appears like your sea level's going down. But you have to take into account what is the volume of water in your oceans doing versus what's tectonically happening on land. Because if you're getting tectonic uplift, and you could have your sea level, your eustatic sea level, the volume of water in the oceans theoretically be just, let's just say for this thought experiment, stays the same. All right, it's flat, it's not moving around.
No
But
more water in your bathtub.
yeah.
well, you turn the faucet off, and the water is just you're at the same level, right? But then we get tectonic uplift, boom, mountain range pops up. It's going to appear that your sea level's dropping, but in reality, it was tectonically influenced.
Right. So just based on the rock record visually, as far as like you're going from silts to fine sands to coarse sands, it looks like your ocean's moving away.
Yeah.
However, they can do geochemistry wise, they can pull different isotopes out of the sediment to actually try to infer temperature, precipitation, and the amount of water in the ocean.
Yeah. So one of the easiest ways to do that, I don't know, I shouldn't say it's easy for the people to do it, but easiest ways to sort of understand it is, one of the biggest ways we add or lose water to the ocean is with ice. And so basically water is H2O. That's a fun fact for you. And that oxygen it basically comes in two types, two isotopes. Go-topes. One of them has a weight, an atomic weight of 16, and the other has an atomic weight of 18. And in the water, 16 preferentially evaporates because it's lighter. If you're picking up boxes and carrying them, or if you're helping your friend move, you're going to take the lighter boxes because it's easier. That's working smarter, not harder.
There you go.
And so preferentially the lighter isotope comes out. And if it's evaporating, goes into a cloud, and that cloud goes over land and then snows and turns into ice on land. If you're forming glaciers on land, you're taking out 16 and you're just storing it on the land. So your water is preferentially getting,
Heavier.
would say heavier. Yeah. So it's getting more, it's concentrating that O18. And so you can look at things that use water or that would preserve that oxygen isotopes, like corals or critters that make their skeleton or shells, using seawater. They lock up that oxygen. And so we can measure the ratio of 16 to 18. And if we see more 18, it tells us that sea level probably was going down because it was colder. There was more ice on land. Whereas if it's closer to balanced, if it's getting towards zero, the ratio, it's probably getting warmer.
Right.
So that's one way. Yeah. Like you were saying, because the example I would give about transgression, regression, you could also have, say you're standing on the beach and all of a sudden you just start dumping more and more sand into your bathtub or whatever. It's going to make the shoreline look like it's moving further into the ocean and make it look like sea level's dropping, when in actuality you're just adding sediment.
Yeah, and there's all sorts of I guess weird things that can happen that have happened in geologic time, that it makes it look like the sea level's going up and down, but it's just kind of more attributed to tectonics rather than just, is your ocean filling up with water even more, or is the water evaporating and, turning into ice?
And I think we've talked about isostatic rebound too. Like there's places in Alaska where it looks like sea level is going down, even though globally we see it going up.
Yeah.
Right.
Yeah.
Because all those glaciers are now not pushing the earth down. So
Yeah.
now because they don't have 2 miles of ice on top of it, it's actually bouncing back up, like taking your hand off that memory foam mattress. But yeah, with regards to tectonics, you have certain events like earthquakes or like sudden thrust faults or something like that can happen instantly. But tectonically, it's usually a pretty slow process. But now I think what this article is getting to, and I'll let you get to it, Chris, is that humans are now affecting some of this stuff.
Yeah.
Humans are affecting the land part of this equation, not just the water part of this equation.
Yeah, and I think this is where I think I misread this article, because subsidence is something like we know about, but offshore. So certain areas, certain coasts, and so this is what we would call regional sea level. Certain parts of the coast, sea level changes differently. And I'm just thinking of areas where you have a lot of sediment from like rivers being dumped offshore, and that weighs the crust down. And this is something we've known about, like New Orleans is sinking because the Mississippi River is just dumping sediments. So, if global sea level is 3.3 millimeters a year, in New Orleans, it's like 13 millimeters a year. But
and
yeah,
I
guess
for a town that's just about at sea level, that's a big deal.
So I guess, yeah, the idea that actually building on the land is causing subsidence too. That's, I never even thought about that.
Yeah. And so, there's just think you have it like, I like using the example of New Orleans. All right. It's already like parts of it's under, like it's below sea level, right? And so what's happening there is you're getting, well, number one, I guess you could say people live there, that there's a large population there, and people like to drink fresh water, right? So where are you getting the fresh water from? We're not getting it from the ocean or the Gulf of Mexico. We're getting the fresh water from wells. We're pumping it from, underground aquifers. That's where the fresh water is. Cool. So now we're pumping the water out faster than those aquifers can recharge. When I say recharge, it's basically just kind of like rainwater percolating down and filling that aquifer back up. It takes a long time for some of these things. It's not just like a thunderstorm rolls through and like, it fills everything up. So, and then it also gets into the different types of geological conditions that you're in. There's some aquifers, especially like out in the Western United States, where it takes thousands and thousands of years to recharge these aquifers. So it's not just, one of those things where you can say, oh, okay, we'll just wait for the rainwater to fill this thing back up. It's like, no, once it's gone, right? But for New Orleans, I don't think we have that problem. I think it's, but anyways, so we're pumping all of this water out at a rate faster than it can recharge. So you're having a net loss of groundwater. And that's one of the reasons for the subsidence there. What's another reason for this? I just had it on the tip. Okay. Oh, the Mississippi River. That portion of New Orleans is set up so that it doesn't flood. When I say set up, it's engineered. There's engineering controls. We have levees that really lock in the Mississippi River. So take those levees out, right? Let's imagine 10,000 years ago, before we had humans in North America, the Mississippi River flooded every spring. And what happens when it floods, it just basically, it dumps a lot of sediment, a lot of fine grained sediment, a lot of silt, clay, sand, and things like that along the floodplain. So it's continually adding more sediment onto the floodplain. So fast forward to present day, we lock up the Mississippi River. We put levees up there. We don't want this thing flooding. We got lots of people living along this thing. The Army Corps of Engineers doesn't want this thing flooding. So they have it set up that the Mississippi River at that lower portion closer to New Orleans basically doesn't flood. What's happening now is you're not getting that sediment getting dumped onto the floodplain. All right. So the land over time, just everything's just kind of getting compacted, and you're not getting any new sediment added on. So that's another reason for the subsidence. In some areas, we're pumping out oil and gas from underground, and so once again, that's going to add to that subsidence effect. And then we talked about like San Francisco, for example, just building the skyscrapers and construction, that's adding weight, and that's causing subsidence. All right, so we have all this stuff. I think I pretty much hit all the big ones there. But so, and a lot of the things that I mentioned are caused by humans. All right, so humans are causing the subsidence. All right, so now the land is being pushed down because of things that humans are doing, and we know that sea level is rising. All right, and so it causes this effect. So what would be like 3 millimeters a year, this article says 2.6 millimeters over on average over the last 2 decades. So we're now looking at a relative sea level rise of like over a centimeter, which is like way more. That's actually what New Orleans is experiencing. They're experiencing a relative sea level rise. We can take into account how much the Gulf of Mexico, the ocean water, is rising. I guess the Gulf of Mexico isn't the ocean, but it works for this example. But how much eustatic water levels are coming up, and then how much your land is sinking down, and you're looking at a relative sea level rise rate of over a centimeter a year, or about a centimeter a year, I should say, in New Orleans. So it's just another thing to add to, I guess, we would talk about, I guess, in terms of climate change, we know that the eustatic sea level is rising. And now it's also, we should start thinking about what are we doing along the coast? Is there anything that we can do to not have the coast subside or basically sink as much as it is in some areas? So just kind of another thought of, like, I guess, sustainability, or I guess, is that the right word to use there? Or yeah, anyways. So that was that was an interesting article there. How we can actually we could prevent some of the subsidence occurring, and potentially have a lesser relative sea level rise. So
it's interesting. I mean, just since 1993, since we've been measuring with satellite, sea level has gone globally has gone up 94 millimeters, almost 10 centimeters, something like that. I can tell you in a second. Since 1993, it has, maybe not. It's going up. I just had it open here, and it's driving
in one of your
crazy.
tabs.
So
One of my tabs, 96 plus or minus 4 millimeters since 1993. So that's almost that's 9.6 centimeters.
Yeah.
Which,
wow.
Which is kind of crazy and so now they're saying that rate is actually, that's undershooting to some extent certain areas.
Jeez.
That's, just in whatever that is, 25 years, that's almost 4 inches.
Yeah, it's almost 30 years, but yeah.
Did you guys see?
Nope. It's 10 years ago. The 90s were 10 years ago.
Did you guys see on the article that I sent you guys? Did you guys see the last line of that? And I didn't know this, but it says one of the main reasons that Jakarta, which is the capital city of Indonesia, Indonesia is moving its capital from Jakarta to Borneo, is because Jakarta is sinking due to groundwater extraction,
Yeah,
shallow wells.
it's crazy. I didn't know that the move was finalized, but yeah, they're moving, which is crazy because I mean the Jakarta has over 10 million people in it.
Yeah.
So it's this is real time effects of the sea level rise and climate change.
Yeah, and like also just, and not only that, but there's also the effects of pulling out too much groundwater.
Yeah,
at a rate faster than it can recharge.
Yeah, like it's like the double whammy here of sea level rising, and then how are we exacerbating the situation?
Yeah, and I know. So like historically, Long Island, New York has had this problem of pulling out too much groundwater. And what happens is you get this thing called saltwater intrusion coming in. So Long Island is right on the coast there. And so once again, humans like drinking fresh water. They don't like drinking salt water. It tends to, what is this salt water shut down your liver or kidneys?
Yeah, it'll kill you.
All of the above, right?
Yeah.
It's
a tiny bit of salt in your water is actually good for you. It helps with electrolytes and things like that, but it's a very, very small amount. You can't drink seawater.
Don't go to the ocean. Start. Yeah.
Yeah.
It makes you, isn't there stories about like sailors that get stranded and they're just kind of like out of the ocean? They start drinking salt water. Doesn't it make them hallucinate? Have you ever heard those stories?
It makes you throw up. Yeah, I don't know. That's where the saying water everywhere, not a drop to drink.
Yep.
Yeah. So anyways, I forget if the salt water shuts down your kidneys, your liver, but
you can cut
really
your water
important.
supply with a tiny bit of seawater to help stretch it. But that's only in extreme emergencies. Like you're on a desert island, you have 2 gallons of water and you think you might last a week. You might cut it with a little bit of seawater to just make it last 8 days.
You might want to consult Bear Grylls on that first before you actually go about that. But anyway, so back to Long Island, there's a huge population that lives there. And they're right on the ocean, and they get their water from groundwater wells, and they're sucking it out. And they're actually sucking so much water out that you get this thing called saltwater intrusion, where it's actually they're sucking in salt water from the ocean into their wells, and then you have a huge problem with the water wells becoming contaminated with the salt water. So you can't really do much with salt water. There are desalination plants, but they're super expensive, and I believe that essentially how you get fresh water from a desalination plant is you basically just boil it off. You boil the water and
you can do it that way, or you can squish it through membranes, but to squish it through membranes takes a lot of pressure, so therefore it takes a lot of electricity.
Either way, it takes a ton of energy.
And places like
the salt,
places like Long Island too, it's not just drinking water. A lot of it's irrigation wells for agricultural reasons too. So that becomes your plants need a lot of water.
South Jersey has similar issues with saltwater intrusion. Same in Delaware.
Yep.
So much ag in Delaware.
Yeah, they actually issue permits, and you're only allowed to pump a certain amount a day because they want to mitigate this problem. So,
and out in the U.S. Midwest, the Ogallala Aquifer, that's is that the one? It's one of the biggest, if not the biggest, of the aquifers in the United States. It's huge, but it's basically underneath the out in the Midwest, we have all the agriculture,
the bread basket.
That's what I was that's the word I was looking for. And they pump that aquifer for irrigation, and they've been having problems. It's just getting smaller and smaller and smaller. And once that thing dries up, then it dries up. It's like I was saying earlier, some of these aquifers, it's not just that, you wait around a year and it recharges, fills back up with water. No, some of this stuff can take like tens of thousands of years to recharge, depending on the geologic conditions.
And they are getting better. They're coming up with better practices for irrigation. Essentially a lot of it was just like spray it on there, whenever, and hope it works. And now they're getting more frugal with the water, realizing like, hey, there might be better times of the day to water it. There may be better soil amendments or perhaps growing different crops at different times of the year, some that are more drought tolerant, like in the peak of the summer versus, so they are getting better, but more needs to be done. So
yeah, this is the problem in the Kiowa aquifer too, which serves a lot of the Front Range in Colorado,
Okay.
where you have, Denver and Colorado Springs. So you have millions of people with more moving in every year. Yeah, and it's this very confined aquifer that only recharges like in a very small area in the Front Range, and they misjudged the recharge area, and so the drawdown, like into the 80s and into the 90s and 2000s, the water level was just like plummeting, and they couldn't figure it out. And it's because they had miscalculated the recharge area, and here it was recharging at a rate that was 10 times slower, I think, than they thought it was.
Yeah.
Ugh.
Comes down to a good cross section in geology.
That's right.
Yeah, you off by an order of magnitude. Oof.
Not good.
Yeah.
Not good.
So,
No,
anyways,
I would not want to be moving to Colorado right now. That was for one of our Patreons who's listening.
Oh, yeah.
Who's moving to Colorado right now. But anywho.
So all these issues with all these anthropogenic issues with with the sea level rise, and it's stuff that previously didn't even go into the calculations before. So but now we know, and hopefully we can come up with the solutions for them, better solutions in the future.
I saw a pretty funny meme the other day. It was a cartoon. No, I guess it was a cartoon. It was the latest Mars rover. And it was pictures of the Mars rover, and it was just a skeleton holding a sign on Mars that said climate change is a hoax. Maybe chuckle.
Steve.
I know, I'm telling you. Sorry, am I getting too political? My bad.
Anyways, moving on. We got this Jesse, you want to do this last article that you had?
Whoa. All right. Well, they found a really old rock.
And that's it this week for the Geology.
Thanks for tuning in.
Thank you.
What was so special about this really old rock, Jesse?
Well,
It was
so
shiny and dark, and
It was actually kind of dark.
It glowed.
It's
maybe want to do evil things when I touched it.
4.6 billion year old meteorite they discovered in the Sahara Desert in 2020, so 10 years ago at this point.
Do they think it landed in 2020?
Wow, that is, you have been bringing the questions tonight.
Sorry.
It's discovered.
Yeah, it was discovered.
No, I know discovered. I just wasn't sure. It's just been hanging out there for a few millennia.
Now I'm looking at the actual article.
No, I'm sorry.
I don't know if that's actually important. That's not what the article.
You're right.
You're right. It's not.
But
I mean,
I'm
in the
just
grand
asking
scheme of
questions.
things.
Yeah.
So in the Sahara, it's just one of the better spots to look for meteorites because, especially if you're out in one of these dune fields, and if you see a rock just sitting on top of the sand out there, then it had to have come from outer space, basically.
More or less. Yeah. It's a blank canvas. It either came from a camel that dropped it or outer space.
Yeah. And that's, the Sahara and like any desert, I suppose, or
Antarctica.
Yeah.
Yeah. If you're then literally there's people that just, I've heard stories about that. People just drive around on what are those things called? The snowmobiles. And they just look for rocks on the top of the ice because it had to have come from outer space.
Yeah.
There's no other way for that stuff to get there. But anyways.
So it's this meteorite is unique because it's the oldest known lava that is so volcanic rock, crystallized lava, and they date it. They put an age on it. They didn't take it out to dinner.
Wanted some wine.
Yeah.
Look directly in its eyes, and
this is sort of crazy here. 4.565 billion years old. Like they got
Man.
that number down. And so
Zircons?
the unique thing, I didn't read that far into it.
Sorry.
Come on.
Steve's
And-
asking
and-
all the questions.
No, and
They're
I
great
apologize.
questions.
Usually, today was an extremely busy day, and it's been an extremely busy week. Usually, I do read up on these things, so I don't ask these questions. But so I apologize.
These are great questions. Yeah, I don't know. Let me see.
I mean, zircons is usually what they use to date really, really old rocks on Earth. So
That's just slam dunk. Yeah, it's a zircon.
yeah, but I mean, there might
Doesn't-
be some. It's volcanic, so there might be some uranium lead.
yeah,
as well.
true.
But this is the interesting thing. Most times when you're finding meteoritic material, it's mafic in makeup. So it's sort of these minerals that you get at higher temperatures. This is would be considered andesite, which is
What?
an intermediate rock, yes, which forms on Earth in subduction zones, plate tectonically derived subduction zones.
And kind of full circle from how we started this podcast,
Yeah.
talking about the age of continental rocks, and you're only getting you're only getting andesite or rhyolite when you're mixing it with continental rocks.
And so the thought here is that it was probably part of some ancient protoplanet that's no longer in our solar system, that either broke up or it collided, just during early sort of accretion. It's collisions and things, impact events that destroyed this early protoplanet. So it's a piece of that you had this, I guess, like fractional melting. So like it's really interesting story here.
Now, why do they think it was within our solar system? I'm sorry.
I guess the age, the 4.5.
Yeah, it's
like,
just
it's
like-
just
the
super
formation of
close
our
to
sun.
okay.
Yeah,
And
that-
Steve, to answer your question, was it a zircon? No, they were looking at this aluminum 26, magnesium 26 crystallization. So that's-
the
I'm-
old ALMG.
yeah, so I'm not really too familiar with that.
I've never actually heard of that age dating technique.
no, neither have I. I'm looking at it. Yeah.
Yeah.
So it's, so there's partial melting going on here, suggesting that it was probably this primordial crust on some protoplanet.
That's amazing. That's awesome.
Yeah,
And, all of these protoplanets, they're just gone. Either they crashed into other planets, our planet included, or they're just destroyed through impact events and make up
But-
rocks hanging out.
But think about it.
blame
If
it on
you-
Jupiter.
if you're in the Sahara Desert and you come across a piece of andesite,
Yeah,
you're not.
Yeah.
I'm not thinking meteorite. You know what I mean?
Yeah.
I wouldn't think to try to date it to figure out how old
No.
it is. I would just say, this is just a rock somebody
Yeah.
dropped.
Volcanic rock that got, yeah.
Yeah.
Yeah, they showed that the magma that made up this rock took at least 100,000 years to cool and solidify after it melted, showing that it was pretty viscous, which is interesting.
Sticky.
hence
Um,
the intermediate composition.
Yeah, and this is a really interesting sort of story here. That age on it is sort of crazy too. That's basically like, I don't know off the top of my head, that the one thing I'm reading here is that it's just 2 million years after the formation of the solar system.
So
Like-
this must have been a small planet for all this to happen so fast.
Yeah.
Because if it had more mass, it wouldn't have cooled down fast enough to have continental crust and or volcanoes and to form that stuff.
Yeah.
And especially if it took 100,000 years just to cool. That's crazy.
So, yeah, I mean, just looking at sort of a rough age of the universe for 4.571. So 4.571, and this is
Wait, did you
4.565.
Real close.
So it's real close to the beginning of the solar system.
Yeah.
Wow. So this meteorite is called Chech 002. Does that mean there's an Chech 001?
Ooh.
Maybe they were like a
We're asking all the questions here.
no, but they could have been a crew of people, a team that goes out into the desert trying to find meteorites.
Huh. The age and that refined age of the solar system of 4.
Yeah, I always say 4.6, but I guess that's not accurate enough.
Here's the most recently refined there's a paper in Nature Geoscience in August of 2010, so semi recently, and they used lead 207 to lead 206 isotope systematics in meteoritic inclusions. Those inclusions, those meteorites were found in the Sahara, but it was 4.568 million years ago, or 4,568.2 million years ago. That is pretty precise.
Yeah, man. That is great. Yeah.
Good for them.
Science.
Yeah. They're doing the work. So
All right, let's go to the Sahara.
yeah. Go find some meteorites.
We'll get some drones. We'll get a little tent for shade, and we'll just fly them all around until we find stuff.
We should do it in like August. Just go big or go home.
Isn't it at the equator, so it really doesn't matter?
I guess you're right. It really doesn't even matter. Oh man.
It's gonna be like a classic movie scene of us. Our clothes will be tattered. We'll just be like crawling.
Yeah.
Water.
Yeah.
Seminac will have a full canteen watching us die.
I'm trying to find the average temperature in the Sahara, but actually,
Well, that's the beauty of deserts. It's probably like 30 degrees at night and 130 in the day. So the average temperature may be misleading and saying like, oh, it's 62.
yeah.
According to Wikipedia, the average high temperature in the summer is 40 C, so 104 Fahrenheit, but it can soar as high as 117.
So like Phoenix.
That's not too bad.
Yeah.
I've been to Phoenix in the summer.
Ugh.
It's not pleasant, but it's doable.
I don't know if I could do 117. That's a little roasty toasty.
Yeah.
What is Vegas is like that too, right? Vegas gets like,
but it's a dry heat, right?
The dry heat, yeah.
None of that means anything. It's awful. It was 68 degrees here today, and I was like, "Oh, this is too hot."
Oh, I know. I put on pants to teach today, and I was like, "Man."
Yeah, I was wearing a flannel when I went outside, and I was like, "Ugh." It's that weird. It's that time of the year where it's like chilly in the morning, so you leave, and then in the afternoon you're like sweating.
Yeah, and my kids hate me because I'm like, you have to wear a coat. Why do I have to wear a coat? Because right now it's 34 degrees out.
They're young. They'll live.
Yeah, I know that, but I get yelled at by teachers in school. So, anywho, but yeah, really, really interesting articles today, gentlemen. I am ever impressed with the ability for none of you to answer my questions. So
you just
what was the name of that? Chech?
Chet, yeah. 002.
Because a Chech is it's like that blue indigo dyed cotton garment that's worn as a veil or a turban by Berber people in the Sahara or the Sahel region, right south of the Sahara.
Neat.
Yeah, and erg means
Erg is like that. That's a geomorphology term.
Is it? Yeah. It's a thing. It's a landform.
Sand seas, yeah.
Yeah. It's a big sand. Yeah, a big sand. You're right, sand sea. It's like it's like a dune thingy.
A dune thingy, a really, really big dune thingy. Yes,
Dune
it's
thingy.
very good. Yeah.
Are those are the ones you see from? They look like long linear things, and you're like, that picture's from space. And you're like, what? Is that the one I'm thinking?
No, I think you're
of?
thinking yardangs. Or
You're a yardang.
thanks.
This is the picture I'm thinking of.
All right, let's see what this is. But ergs are also known as sand seas. They're just What is this?
It looks like a microscopic picture of a fingerprint.
It looks like you got some parabolics and linear dunes.
And this is the classic one. This is sort of like a classic picture. I mean,
oh, that's beautiful.
Yeah,
makes you want to go surfing down it.
You know, I was fun story. Won the podcast with this, but good friend of the show, Matt Sophie, who's just here 2 weeks ago. This makes me think of him. We were driving back from. He was living in Reno. We were driving back from.
But real quick, we did have that episode with Matt Sophie, and then like 6 days later, there was a gigantic earthquake in New Zealand. But Matt is okay. We checked on him. Yeah. So carry on.
Well, so for the people listening to the podcast, Jesse just sent this like beautiful picture of like your classic like desert dune, and just it looks like you go sledding down it, right? So Matt and I are driving back from Las Vegas to Reno, where he was living, and we saw there's like these like sand dunes, like I don't know, a couple miles off the highway, and I was like, let's go check those out. So we go, it's just a couple mile detour, so we go off there, and we just kind of run up these sand dunes, and I was like super excited. I was like, I'm going to go jump off the sand dune, just go sliding all the way down. Jumped off the top of the sand dune, went about 3 feet and stopped. And I was like, oh, this was so depressing. I was like, oh, I couldn't go anywhere. It was
so let down.
So let down. Yeah. So, but
goes to show you need to know how far your sediment has been transported before you go sledding down it.
Yeah. Apparently, though, if you go to Sand Dunes National Park, which I've been there, you could rent out these little like wooden boogie boards and boogie board down the side of the dunes. I didn't try it because I was still salty over my last sand dune experience. Nice. I know how this ends. All right.
Fool me once.
You guys want to call it quits for the day?
Yeah, buddy.
Yeah. Right. This was nice. I enjoyed this.
Yeah, I like a little news article episode every now and again.
Yeah.
Keeping us fresh.
Learned some things. It was great.
Yeah. Good times.
So thanks everyone for listening. If you'd like to help out the podcast, help us with keeping the podcast up and running. We have a Patreon page, patreon.com/Geology Flannelcast. And we have different tiers of Patreon sponsors. Tiers start at as little as $2 a month. We'll hook you up with some stickers, and you get to help out the podcast. Other tiers, you get to hang out with us before the podcast starts, chat with us. We have lots of fun. You get to hang out during the while we record the podcasts. Or if you become the Topaz tiered member, you give us a topic and we will talk about that for an entire episode. So anyways,
just try not to make it too difficult of a topic.
We're working on one right now. That was it's a little bit of a kick in the pants. So
yeah,
it's good. It gets us outside our comfort zone.
It's definitely a master's level question. Life ?
Yeah.
But yeah. Maddie, I know you're listening. We're getting to it. Don't worry. Getting to your topic. But anyways, yeah. So you can help us out on patreon.com/Geology Flannelcast. Or we also sell some merch that helps out. Every little bit helps as well. You can just straight up buy some stickers off of geologyflannelcast.com. We have coffee mugs, t-shirts. Steve's holding up his Geology Flannelcast t-shirt right now. So all that can be found under the merch section on geologyflannelcast.com. Check us out on Facebook, Geology Flannelcast, Twitter. We're at GeoFlannelcast. And hit us up, shoot us an email. Let us know if you like the show.
The Flannelcast on Facebook is killing me because I gave up Facebook for Lent. And so I have to go in, do all our Flannelcast stuff, and then exit quickly.
Not looking at anything else.
Because I'm old. This is my only entertainment is Facebook anymore. So anyways, all right. And by the way, all of the articles we talked about today on the podcast, I'll post them on geologyflannelcast.com under this episode. I think this was 85. It indeed was 85.
Episode 85. We got some plans for episode 100 is coming up pretty soon.
Yes.
That's in 15 weeks from now.
Yeah, and another teaser. We do have the Origins of Life coming up soon, but we're also hoping to get one of the friends of the podcast back on.
Who could that be?
Good friend of the podcast.
Good friend of the podcast, which is not Matt Sophie. So that should narrow it down.
It's actually an attempt to one up Matt Sophie.
It is indeed. So anyway, there's a little teaser for you, but can't wait.
Cannot wait. It'll be good, I promise. All right, everyone. Thanks so much. Thank you so much for listening. We love you guys, and we'll catch you next week with another fun and exciting episode of Geology Flannelcast, the premier geology podcast.
Check you later.
All right. See you later.
Bye.
That's
Thanks
not making the cuts.
by.
It's not.
All right,
I won't stop.